paper. The first question is basically a theoretical question. Name the different types of ICs and compare them to each other. This is the block diagram, and the complete description for each and every ICs are given below. Next is draw a PLA structure, name the different components and state the use of these components. So this is a PLA structure. Normally a PLA consisting of a programmable AND array and a programmable OR array. These are some of the usage of PLA, where the both AND and OR are programmable, and AND array can be programmable to get a desired min terms. That's the main usage. And any boolean function in a soft form can be implemented using PLA. This is the structure for PLA. So it is one example with 3 inputs, 4 inputs, B0, B1, B2, B3, and 4 outputs, E0, E1, E2, E3. You have taken a input buffer inverter for the inputs, and based on the number of product terms, we have taken total 9 product terms here, and based on the number of outputs, we have taken 4 possible OR arrays. So like this we have a programmed based on our SOP expressions. So draw the FPGA structure. This is FPGA structure consisting of interconnect wires, programmable interconnects, and these are called IO blocks, input output blocks. These input output blocks are mainly for interfacing. These are some of the advantages of FPGA block is mentioned. So coming to lookup table, suppose for example I want to implement a lookup table. So this lookup table is given a function with 2 input called x1 and x2 with one output function f1. So here this equation is given. So based on this, if you take x1, x2 are 2 possible inputs, f is your output, 0 0 0 1 1 0 1 1. If you substitute 0 0 here, answer will be 1. Substitute 0 1 here, you will get answer 0. Substitute 1 0 here, you will get answer 0. Substitute 1 1 here, you will get answer 1. So how to implement a lookup table for this particular function? As 2 inputs are available here, based on these 2 inputs, considered a 2 input LUT. 2 input LUT. So this 2 input LUT you have to memorize as it is. So here it consisting of a first level a 2 input muxes, second level also we have 2:1 muxes. These are memory elements capable of storing both 0 and 1. As per our requirement, we have 1 0 0 1. That's why we are keeping only 1 0 0 1, and we are discarding 0 from here, 1 from here, 1 from here, 0 from here. So this is the LUT implementation for this given function. Okay, this is design of 1-bit boolean logic. So just a standard library declaration for the 1-bit adder, entity declaration, next this is the architectural declaration. These are the equations we have written based on the sum equations and carry out equations for a 1-bit adder. As we know very well, the standard equations for sum and carry out equations, based on these equations we wrote the expressions. So coming to another question, drive the okay, already we have done this 3-4 bits we have completed here itself. This is your A, this is your B, and next another thing is write down all those stuff in your own words. Okay, as already the word description file already I mailed to you. From this you can get an idea about how to write a word description for this particular codes. Coming to another very important question, sequential logic question. Design a circuit that increased 3-bit output